we have the pleasure of our chairman today giving us the talk, which sounds very interesting. So would you please welcome Chris James, who is going to let us know what happens in the heavens and above.
Okay, well, the talk this afternoon is, you can see, astronomy the last 25 years, and we're looking essentially at the years 1992 to 2017. Why choose those years, I suppose? Well, basically, I'm sure I speak for everybody in the room here. In 1992, I wasn't even born, so I thought that's probably all right. Okay, that is what the night sky should look like if you haven't got any light pollution. That's from the Isle of Wight, and that's, of course, the Milky Way through here. And very few of us now can see that. I can remember when I was a kid, you could see the Milky Way plainly. You can't see it now. Okay, so what's astronomy all about? Well, it's essentially about the sort of study of the skies, really. And study sounds a bit po-faced. It's a bit like doing homework in school, isn't it? Part of it is just really sort of observing the heavens. You can just look with the naked eye, people with binoculars, telescopes. And of course, there's these huge telescopes which we've got now. And they tend to be places like sort of up in the mountains of Chile, or on Hawaii and places like that. And the reason for that is to try to get above as much of the Earth's atmosphere as possible. The atmosphere absorbs an awful lot of the rays which come from space, and it also sort of distorts the view you get. So you sometimes don't get very good views. So the further up you can put it, the actual better it is. And of course, the best place at all to do this is up in space. And there's this thing called the Hubble Space Telescope. And this is it being deployed. And this, of course, is the space shuttle, which delivered it to where it's going to go. And it was actually deployed on April 25th, 1990. Which is a little bit before we're talking about, but I think we can sort of get round that, because when Hubble was first set up, the images it produced were something like that. And the main mirror for it had actually been ground incorrectly. So they had to send another space mission up and really give it a set of glasses, really, to correct the where it was going wrong. And this is in 1993, which sits into to where we want to be. So some of the images which Hubble has taken, the pictures you're going to see from Hubble now were all taken within the last 25 years, most of them within the last 10 years. So they're pretty up to date. That's home, of course, planet Earth, Africa here, Madagascar, Saudi Peninsula, Red Sea, all that. Not too much cloud cover there. Beautiful looking world, isn't it? Home. That's our moon, of course. If you look at that through, well, binoculars or a telescope, the sheer violence which has been done to that over the years is got to be seen to be believed, actually. And that's the power source, of course, for the solar system. This is our sun. Sort of mass coronal ejection going off there. Not very much in the way of sunspots on that. We're at the moment what's called solar minimum. There's really not an awful lot going on the surface of the sun at the moment. This is the planet just out from us. This is Mars. I'll be talking about Mars in a bit more detail a bit later on. So if you just bear with this. This is one of Mars's moons through here. Again, has been picked up by Hubble. Jupiter, easily recognizable by the great red spot. And here's the interesting bit. That's an aurora on the north pole of Jupiter. Northern Lights. Okay, this is our next door neighbor. This is the Andromeda galaxy. Now, if you look up in the night sky tonight, everything you see with the naked eye belongs to the Milky Way. Exceptional one thing, and the one thing is this. Say this is our next door neighbor. Actually, the galaxy itself is pretty faint, and the only bit you're actually going to see is this central piece here, and that just looks like a little star up in the sky. You really can't see very much of this. Now, if the Andromeda galaxy was brighter, then what you would actually see in the sky is that. This is the moon, crescent moon here. Look at the size of this thing compared to the moon. It's absolutely massive. I mean, this has nothing to do with Hubble. It's just something which I got off. I think it's really interesting. This is the closest galaxy to us, and in astronomical terms, it literally is next door. And they're actually gravitationally linked. Andromeda galaxy and our own galaxy, which is the Milky Way, are linked. And they are moving closer and closer together. So in a few billion years' time, they are actually going to collide. We're going to collide with Andromeda, with all the bangs, crashes, and thuds which that will entail. So I thought that was a really interesting photograph. Okay, so we'd have a look at Mars, and there are one or two rovers up there at the moment, and what I want to concentrate on is one called Curiosity, which has been up there now for a number of years. And this is the rover itself. This is Curiosity actually on the surface of Mars, and that is a selfie which the probe has taken of itself. And I think that's one of the best selfies I've known, actually, and I can give 3 reasons for that, I think. And that's location, location, location. Pardon? NASA. North American Space Agency. Right, this is an artist's impression of Curiosity moving around on the surface of Mars. You've got 2 choices here. It actually is on Mars, or it's moving around in a studio in Hollywood somewhere. So it's up to you which one you think is more feasible. That's an actual photograph which Curiosity has taken. Looking backwards, these are going to say tire tracks, but the wheel tracks that Curiosity has left on the surface here. You can see the surface of Mars, pretty barren sort of place. Oh, that's not a very good photograph. That is the sort of surface that Curiosity has got to sort of get round, so it's pretty treacherous, really. The point of the rover is to actually do exploration on Mars, and this is one of the first drill bits which were put down, which is here. And one of the things which Curiosity is looking for is any sort of signs of life, any sort of fossil evidence. You're not going to find little green men or anything like that there, but you may very well find sort of fossil life, and certainly Curiosity is programmed to actually do that. Again, here's another photograph of the surface of Mars. You've got sort of sand dunes through here. And that's a sort of panorama. I mean, that really does look like the Badlands of America, doesn't it? You know, but I mean, you are actually on another planet there. Right, this is what it's, oh, sorry, the top bit's gone off. This is what Curiosity has done. It landed up here. It's been around all these places and has done exploration in all these places with triangles. In July this year, it was there. And the idea now is there's a mountain here called Mount Sharp. And it's going to go up there and do some more exploration through here. And that's a photograph of Mount Sharp. And Curiosity is going to go up at least part of that and do some exploration as to what we've got there. If you ask the question, has life yet been found on Mars, the answer, I think, must be a categoric yes. Look at that thing there. This is a photograph from Curiosity. If you blow it up, do we need any more evidence? I mean, I don't think so. Which brings us nicely on to this. And this is what is called SETI, S-E-T-I, and it stands for Search for Extraterrestrial Intelligence. And basically, you're looking at little green men that we can communicate with. Aliens, of course. And some aliens are going to be quite nice, and other aliens might not be. I can remember a famous scientist once said when SETI first started up, he said, for goodness sake, shut up, somebody might hear you, which is a point of view. Okay, this is the sort of stuff which SETI uses. It doesn't use very, very big antennae. They find that you get a lot better results if you use an array of quite small ones. I don't quite know what the diameter, I think it's about 3 meters if I recall. They're not big, but if you use a lot of them, you do tend to get better results. I suppose SETI really started getting in motion on the sort of start of the radio age, really. So you're looking sort of late 19th, early 20th century when the thing started taking off. And people found that they could communicate great distances using radio. And you've got all sorts of claims being made. People claim to have contacted Martians, and there was all sorts of fun and games going on. So that's the sort of thing which we get at the moment. Now, the sort of thing which we're looking for, you need to find a planet in what's called the Goldilocks zone. You all know the Goldilocks story with the porridge, and one bowl was too hot, the other bowl was too cold, and the bowl in the middle was just right. And this is where the Earth sits, of course. Further in, it's too hot for life. Further out, it's too cold. And there's an area in the middle here, which is called the habitable zone, where it's just right. And that's luckily where the Earth is. Mars is as well, funnily enough. So we've got 2 planets just in our own little solar system which are favourable for life. So that's the sort of place where we need to be. Hold that thought. We'll come back to that a little bit later on. Now, there has been one major success on this, and this is it. When you're trying to communicate with alien beings, the most common element in the universe is hydrogen. And you can actually model hydrogen mathematically. And that's the sort of signal which we send off. And what happens is you get a whole night loads of results coming in. Nobody mans these places, but the next morning somebody will come along and pick them up. And one day this guy came along, picked up the last night's results, quickly went through it, and came across this. Now this is just numbers, of course, to us. But that is a mathematical model of a hydrogen atom. And he was so impressed by this, he wrote the word "wow" on the side. And it has since become known as the wow signal. And unfortunately, it is the only signal we've ever received from space which looks anything like it. Nothing really has been discovered. So much so that what's been found with the SETI program has been called the Great Silence. There appears to be nothing there. And that begs the question then, where is everybody? It's a paradox. If you do the statistics, then actually the universe and locally to us should be absolutely teeming with intelligent life. There should be an awful lot of it up there. We haven't heard a dicky bird, nothing. And it's called the Fermi paradox, after the Italian scientist who first dreamed it up. And at the moment, we've got what's called the Great Silence. There is absolutely nothing coming back to us. I don't know, he pays your money and takes your choice on that one, I suppose. It's supposedly an alien world. It's an artist. Oh, no. Yeah. Okay, moving on. This was a probe which is called New Horizons, and it was sent out to look for Pluto. And Pluto's had a bit of a checkered history, because when New Horizons first started off, it was a planet. And by the time the probe got there, it wasn't. It had been downgraded. And the reason for that is that Pluto is rather odd compared to all the other planets which we've got around. So at one time, these are the 8 planets, 4 rocky ones, 2 gas ones, 2 ice ones, and Pluto is way out there. It was the 9th planet for many years, first discovered in the 1930s by an American called Clyde Tombaugh. It got downgraded, really, because it's got some very odd idiosyncrasies. All the other planets, including us, sort of go like this. Pluto's orbit is most peculiar compared to some of the others. All the others do that. Pluto does this. So it doesn't seem to really sort of fit the mold of the other ones. Occasionally, Pluto's orbit goes inside of that of Newton. So you've got 2 planets sort of crossing over one another, which again is very odd. So that was a bit uncomfortable if you look at that. As astronomy improved, then you got to know that round about where Pluto was, they're called Kuiper Belt objects, and there's an awful lot of them. There's Eris, there's Makemake, Haumea, all that, and they're roughly the same size as Pluto. So the decision was made, well, why on earth is Pluto a planet when all these aren't? And it seemed to be there wasn't any reason. So Pluto has been downgraded. This is the scale. This is the Earth here and our Moon, just to give you an idea of the scale of these things. They're pretty small things. Pluto's always been a bit of a mystery. That is about the best photograph you can get of it from Earth. And it doesn't really tell you anything, does it really? Except you've got some sort of spherical blob there, but you can't really see anything on that. And to be honest, even Hubble struggles with Pluto. That's about the best image which Hubble has managed to take of it. And hence, the New Horizons probe was set out to explore it in greater detail, really. And that is a makeup of what the spaceship looks like. And this is what Pluto actually looks like. Quite complicated, not a simple world. You've got craters, all these areas here are craters. This isn't. So this area of the Plutonian surface is active. It's moving. And it's felt this is methane ice through here. It's moving around, it's dynamic. If craters go in here, then they quickly get sealed over. Again, there's going to be science coming out of this for years to come. This is sort of a lowlands, where you've got the darker areas here, they're sort of more mountainous, and this is sort of somewhere in between, really. Again, this is a sort of mountainous area in Pluto. Lower areas through here. And there you can, Horizons is just, New Horizons is just sort of leaving Pluto behind here. And you can see the atmosphere through here, various layers of it. So Pluto does have a thin atmosphere. This is not the end of New Horizons. It's taken an awful lot of photographs of Pluto and the surrounding sort of moons. But it will go off into what's called the Kuiper Belt. And this is a sort of series of asteroids and small planets which sort of sit way out in the solar system. It's left the plutonium system now, and it's going out here. And it's aiming to meet up with a Kuiper Belt object. I think it's January 2019. So watch this space. There should be sort of more photographs coming back if the mission is not finished by any means. Okay, if the last 25 years has been a golden age for astronomy, but I fear the same is not the case for cosmology. And I've called this bit Gone to the Dark Side. So what's this all about? This man. This is the cover of Time magazine for December 1999. And as you can see, person of the century, Albert Einstein. I don't think many people would sort of argue with that. No, actually this cover is a little bit of a swizz, because the normal practice in this sort of thing is that the magazine, in this case Time, would ask its readership, who do you think you want to be, person of the year or person of the century or what have you. And this is what Time actually did. They sent out a questionnaire and said, who do you want to vote for as person of the century? And the great American public came back and voted for Elvis Presley. Now, Time magazine just had a nagging thought that perhaps Elvis didn't quite have the gravitas to be person of the 20th century, so the editorial board made an executive decision and decided to put Albert. But say it was a bit of a swizz, because the popular vote went for this guy. Okay, Einstein, of course, is well known for the theory of relativity. And it's a very good theory in that it makes predictions about what should happen. If the theory of relativity is correct, then A, B, C, D, and E ought to be observed. And one of the things which Einstein predicted was that large bodies, say galaxies or our own sun, for instance, would actually bend light. The gravity would bend the light. So if you've got an object sitting behind, what you'll actually see is this. And you will get the impression that the galaxy as it there is off here. Of course, it isn't. The light has been bent around this large object. And this was how the theory of relativity was first proven to be correct. And it was done by an Englishman called Arthur Eddington, who made some photographs during a total eclipse of the sun, and found this to be true, that where a star ought to be, which was there, it was actually shown in the sky as being there. So the gravity of the sun had altered the position of these things. And it's because of this large sort of mass in the middle. And as you can see here, you get multiple images. Instead of just seeing one galaxy, you'll see 2, 3, 4 images of it. And again, this was predicted. And this is a photograph, and it's an example of what's called an Einstein cross. And this, and this are all actually the same thing. It's just that the light has sort of been bent by a big mass in the middle, and you get these multiple images coming through. This is a bit more complicated one, but the same principle applies. That, and that are all the same. They're all quasars. That, and one of these up here, which I can never remember, I think is that one, are all the same galaxy. And so what's happened is that the light has been bent round. And Einstein's theory of relativity, again, predicts this, so you've got some confidence that the theory is somewhere in the right sort of ballpark. Now, the problem you had was when you came to something like this, and this is called Abel 520, very romantic name. And what you have here is gravitational lensing, which is what this is called. 1, 2, 3 here. And you're getting light being bent. Unfortunately, with this one, There is nothing in the way. That doesn't seem to exist. There's nothing there. You can see right through it. If it was a black hole or a massive object, then you would see traces of it. There's absolutely nothing there. Question, why? What on earth is bending this light like this? That apparently doesn't exist. There's nothing there for it. And what they've come up with is a substance called dark matter. Ingredients, nobody really knows. If you figure it out, let us know. And basically, this is it. Dark matter has been postulated. What it is, no idea. Nobody's got a clue. But something is there. Something is causing this the light to be bent. It's not just dark matter. The plot thickens with this. There's also stuff called dark energy, surrounded by mystery. So what's this all about? Well, this is a schematic of the history of the universe as we are today. And the universe came into being in a thing called the Big Bang, which happened 13.7 billion years ago. And it immediately expanded very, very rapidly in a process called inflation. Again, I won't get into this in any great detail. And it's been expanding ever since. And you can show this, you can actually measure this. If you look at all the galaxies up in the sky, they're all moving away from us. And the further away they are, the faster they're moving. Now, if you rerun this in reverse, if they're all doing that, and if you sort of mentally bring them all back together, they all came together in a point. Now, this is fine. So here's what you've got. Universe starts off here, getting bigger and bigger and bigger, and so on. Difficulty you've got is that the universe is expanding a lot quicker than it should do. There isn't enough energy and there isn't enough matter in the universe to make it expand in the way that it is doing. And to get round this, they've come up with material called dark energy. And again, nobody knows what this is. Made from, I haven't got a clue. So we've got two things now. We've got dark matter and dark energy. And if the theory of these dark materials is correct, then the composition of the universe is something like this. Visible matter. That's me, you, this, the table, the chair, the carpet, the air, everything else. Makes up 5% of the universe. Dark matter makes up 27%, dark energy 68%. So if this theory is correct, 95% of what the universe is made of, we haven't got a clue. We really don't know. Interesting. I mean, all the philosophy, all the science which has been done for 2,500, 3,000 years, we finished up knowing a little bit about 5%. We don't know anything about 95%. Okay, this is another one. This is called Cassini, and it was a probe to Saturn, the ringed planet, famous ringed planet. And this was a tremendously successful mission. It actually was at Saturn, taking photographs, readings, and doing all sorts of science for just under 14 years, a few weeks short of 14 years. Which is absolutely phenomenal, really. Just a couple of things. It was looking at the atmosphere. This is what is called the Great Storm of 2010, which has been photographed quite well. Again, these are close-up pictures of Saturn's rings. Absolutely stunning, isn't it, this? Stunning stuff. What I want to concentrate really on, I mean, there's science in here we can talk about for hours, but I want to quickly have a look at some of Saturn's moons, and here are some of them. Now, on Earth, of course, we're lucky in a sense in that we just have one moon to worry about. At last count, Saturn had 62. Possibly there's even more. They vary in size. The biggest one is Titan, which is this one here, and there's very small ones like Hyperion. We'll have a quick look at some of these now. There's two in particular I want to have a look at for you. This is a moon called Ipetus, and it's called the yin-yang moon, after the sort of Chinese symbol, you know, the dark and light. It's got one half of it is dark, and the other half of it is light. And what's happening here is that the material which is coming here is falling back onto this side. So it's a peculiar moon. If you look at it on one side of Saturn, you can see it clearly because you're looking at that side. If you look at the other, it's practically invisible because you're looking at it from that side. This is another moon. This is called Hyperion, and this is a most peculiar looking thing. It's got that sort of spongy sort of texture to it, and it's thought essentially this is probably a captured asteroid. It's an asteroid that came a bit too close to Saturn and has been captured by Saturn's gravity, and is now a moon. I mean, that's the most peculiar shaped moon for a moon. It doesn't look like a moon. And this one is called Mimas, and it's called the Death Star moon. And I don't know why they call it that, really. But there we are. But there's two in particular I want to have a look at here. And this is the moon Titan, and this is the moon Enceladus. And Enceladus is quite interesting because it's the most reflective body, as far as we know, in the solar system. It's even more reflective than Venus. You know, Venus is very bright in the sky. This is even more reflective. Question, why? Nobody really knew. Titan, again, was quite interesting. And we'll have a look at Titan in a bit more detail. Here's the size of it. This is the Earth. Moon. Titan is that big. It's actually bigger than the planet Mercury. It's absolutely huge. It's the second, as far as we know, the second largest moon in the solar system, second only to Ganymede, which is one of the moons of Jupiter. So it is very, very large. And there's been a few flybys of Titan before Cassini got there, and one of them was by the Voyager spacecraft, and it demonstrated this. And Titan has an atmosphere. Now, this is very, very odd for a moon. Question, why? What's it made of? What's it doing? Blah, blah, blah. And Voyager also took some radar images. You can't see through this. It's too thick. So visual cameras aren't any good. You can't get down to the surface of Titan just using visual work. So you use radar. And what they came up with was that. And this is a photograph from Voyager. And one thing that got everybody very excited was this. A flat area there. Now, the only thing which can make radar behave like that is liquid. Now, you are definitely not going to get liquid water on Titan. It's far, far too cold. Water on Titan would have the consistency of stainless steel. It would be absolutely huge. So this is something else. One of the candidates for it was actually methane. And methane would be able to be liquid at these sort of temperatures. So that was really very odd. So when the Cassini mission went up, there was actually a second probe was put on it. And this was called Huygens, which was named after the Dutch astronomer. And it's here. This is the Huygens probe. And it was sent down through the atmosphere of Titan, like this, an artist's impression. They used a parachute to drop it through the atmosphere, and it landed successfully. Now, this is the most distant man-made object ever to land on a moon or planet anywhere else on the solar system. So this is the most far out that human beings have ever gone. As it came through the atmosphere, it took photographs, So you've just got the atmosphere here. You've got sort of mountains, valleys here, more mountains than that as you come down. Very barren looking place. And that's a photograph of, that's not a very good, I do apologize. That's a photograph which Huygens took of the surface of Titan. And what is really interesting about this is these things here. And what you've got are rounded stones. Now, what makes rounded stones on Earth? What makes stones round on Earth? Liquid. Running liquid. So is this an indication of some sort of liquid on Titan? That's the only thing which does it. And you've got rounded stones here. There's no square. That's not spherical, but it's not got any sort of sharp edges on it. Hello? This is an actual photograph from the surface of Titan. Again, an artist's impression as the parachute has landed here. So it's an artist's impression, but what you've got here is correct. Rounded stone, rounded, rounded, so on. So you're looking here at moving liquid. Odd, on a little moon. Never come across this before. Cassini then started taking photographs, and instead of just that little bit which you found from Voyager, you found there was loads of them. Here, 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 there, so on and so forth. And wherever you look, you find these lakes. The only thing in radar which can do that is liquid. So there's some sort of liquid up there. And this is a very, very big lake, as you can see. This is actually a real photograph of the surface of Titan. And in comparison, this is Titan here, here's the lake. This is Lake Superior in North America, the largest of the great American lakes. Look at that, that's bigger than that. This is absolutely massive. Another thing to look at here, ignore the Lake Superior one for the moment. Look at this. You've got river systems. River systems, moving liquid, rounded stones. This is where it's coming from. And again, more in close-up. This again is the surface of Titan. River systems. River systems through here. Now, on the Earth, you have what's called the hydrological cycle. You've got oceans, lakes and that. You get evaporation from that. You get transpiration from plants. This goes up into the air. Condensation goes over hills or mountains. You get precipitation. Either rain or snow, depending what sort of climate you're in. So you'll either produce rivers or little streams, or you produce glaciers, again, depending where you are. And so it goes on. The water then runs back down, runs into the ocean, back up again, and so on and so forth. It's called the hydrological cycle. On Titan, you get what's called the methanological cycle, where you've got methane is acting the part of water on Earth. And you've got these methane lakes, evaporation, methane clouds, precipitation, and so it goes round and round, round and round again. What would happen on Titan, because the gravity is quite a bit less than it would be on Earth, the precipitation which you get in is going to be about a centimetre, maybe even the size of a golf ball coming down. And because the gravity is so much less than Earth, and what they would do, they would float down through the atmosphere a bit like snowflakes do on Earth. So you'd have these great big golf-sized drops, but they would just drift very gently and very quietly down. And what Huygens also found when it was going down is that on Titan you have complex hydrocarbons, which you'd expect if you've got a load of methane around. Complex hydrocarbons can mean life. So you've got a sort of a moon way out into the solar system, possibly with some sort of life on it. This is another moon I want to look at. This is one called Enceladus, and this is also really quite interesting. Now, they are of very different scale. Enceladus and Titan are say very different in size. Titan is bigger than the planet Mercury. It's a huge thing. Enceladus actually is very small. This is the scale. This is the British Isles. Through here. There's Enceladus to the same scale. Enceladus would fit nicely between Cardiff and Swansea. It is very, very small. And because it is so small, there's no way it's going to have anything like a magnetic core, or it certainly isn't going to have any liquid on it. The gravity is far too small for that. So you're looking essentially here at a dead world, really. But, as I said, the one thing which really is of tremendous interest on this is that it's highly, highly reflective. It really does shine incredibly bright, far more brightly than it should do. Question, why? So Cassini was given the task of finding out a bit more about it. Now, this is the southern pole area of Enceladus, and these stripes here are quite interesting. They're called tiger stripes for no apparent reason. They all do have their own name, which I can't remember and I won't bore you with, but they do have their own names. And I say this is them in a close-up. Here, here, and here. Now, what was very interesting is if you actually look at these through thermal imaging, you have a look at what the temperature is on this, you get that. Now, these things are hot. Now, this is the equivalent on Earth of Antarctica being hotter than the Sahara. Weird. What is going on here? Nobody knew. Anyway, Cassini was going around Enceladus for quite a while, and this was the photograph that blew everybody away. It's Enceladus is here, setting behind the sun. Look at this. Plumes of something coming out. Now, this appears to be from the tiger stripes at the bottom. Now, we know from the size of Enceladus that there shouldn't be anything there. This should never happen. This is impossible. But it is. There's something going on here. And this is when scientists got really, in capital letters, really, really interested in Enceladus. So how can we tell what this is? Well, we actually have a spacecraft, which is actually going round and round. So what we do is we program it to actually fly through this, fly through these plumes, and take samples of to what it's flying, what it's actually going through. And this is what they did. They got hold of the Cassini spacecraft. And this is an artist's impression. This is supposedly Cassini here. And these are the plumes there. Again, a bit of a closer one. This is the Cassini spacecraft. What they found was, this is water. Now that is impossible. Enceladus is a tiny little world. How can it possibly have water on it? And yet again, it was found there were hydrocarbons in it. Very interesting. So what's this all about? Well, what is happening is there appears to be some sort of ocean through here, and the top of of Enceladus is really an ice sheet. Now, what happens was the water through here actually gets heated up because of hypothermal circulation. I'll tell you about that in a minute. And because it's warm, it gets put straight out into the atmosphere. Now, because it's water, as soon as it hits outer space, it freezes. And it turns almost immediately to ice. And an awful lot of the ice just falls straight back onto Enceladus again. Hence the reflectivity. It's an ice ball, essentially. And that's why it's so you can see it so very clearly. The other problem was, where on earth does this come from? Enceladus is just far too small to have any hot core in the same way that Earth does. You know, we've got the sort of molten core in the middle. This is nowhere near that. And the answer seems to be that Enceladus' orbit around Saturn is not circular. It's elliptical, which means that sometimes it gets closer to Saturn and sometimes it's further away. And what this does, it produces sort of, it's like a sort of rusty squeeze box. It's sort of squeezing the center of Enceladus all the time. So this then produces liquid water. And as I said, you've got water, and you've also got hydrocarbons. Again, you're looking at possibly life. So again, we are going to go back to both Titan and Enceladus for obvious reasons, and there are some very interesting things going on here. That's one of the last photographs which Cassini took. Again, giving you an idea of what this is looking like. Remember, we looked at the habitable zone. And this is it through here. This is our own solar system, just to give you an idea. So both Earth and Mars are within the habitable zone. Saturn is way out here. It is nowhere near what you'd call the Goldilocks zone. Not a hope. It's a long way out. But potentially, there are two moons on that which have got life on them, potentially. We'll have to get back and check that. But certainly that's what we seem to be. Okay, so we come back to Hubble. So let's have a look at some of the other things which Hubble has taken for us. This is what is called the Great Hercules Cluster. And what it is millions, billions perhaps, of stars which are all connected gravitationally. And if you were on a planet going around a sun in there, I think your view of the universe would be most peculiar. It would just be stars wherever you looked. It would be nothing like we see the universe from our little planet. So that's quite stunning. This is what is called, this is a galaxy, of course. It's called the Pinwheel Galaxy. And it's one of these spiral-armed ones. Classic sort of picture. Not all of them are face-on, of course. This is what is called the Sombrero Galaxy. See that? Sort of got the hat here, the Mexican sombrero through there. It's an edge-on one, and you can see all the sort of material on the side of the galaxy there. This is one called the Whirlpool Galaxy, and I mentioned that Andromeda and the Milky Way are going to collide in a few billion years' time. Well, this has already happened with this one. You've got the major galaxy here, and it's picked up this rather smaller one here, and the two now are sort of linked gravitationally. And those of you who've got sort of an artistic disposition might sort of recognize this one. This is a picture by Vincent van Gogh called Starry Night. Look at this. Exactly the same. Van Gogh was inspired by, this was discovered about the same time that Van Gogh was doing his paintings. So this is what inspired him to produce that. This is the remains of what is called a supernova. This is the Crab Nebula, so it's called. This is quite a new one. This exploded, or was seen to explode from Earth in the year 1054. And there are various reports of it all around the world. Essentially what you've got here is a great big star in the middle there, which is basically blown up. It's one of these big things that go bump in the night. So that's a really good example of one. This is another one. This is called the Cat's Eye Nebula. The remains of a star are there, and again you've got all these shock waves coming off. Highly dramatic. You know, there's an awful lot going on there. Now, both the Crab Nebula and the Cat's Eye Nebula are fairly new in terms of supernova. This is what's called the Veil Nebula. And this has a look of age about it, and old it certainly is. This is a supernova that went off, oh, goodness knows how long ago. And basically, there's very little of it left now. It's dispersing through the universe. That's going off, this is going off. And give it another couple of billion years, and you won't even notice that it's there. So what we do with this is very, very big in the sky. What people do is look at parts of it. And this bit here is called the Witch's Broom Nebula. And in close-up, that looks like that. And again, there's an awful lot going on here. So it's the remains of a supernova. Now, this is a thing called the Orion Nebula, and this is really the opposite to the supernova which we saw. This is an area of star formation. There's a cloud of dust here, and where you see these bits and pieces here, this is where stars are being born, in that the dust is all sort of coalescing together and coming together to form suns like we have. Again, the dust cloud which is here, and again in a few billion years or so that will all be gone, and it will all just be stars. And just up on here, I think it's in this part, you see the famous thing called the Horsehead Nebula, and this is part of the Orion Nebula. And this is probably the most iconic image which Hubble's taken, really. It's called the Pillars of Creation. And again, it's areas of star formation. You can see this here, here. And this is an area where stars are actually being born. Now, one of the last things which Hubble did, you can get very, very good views from Hubble. And what they did was deliberately set it to look at an area of the sky where there was nothing, as far as we knew. Nothing existed. And Hubble was sat on this, I think it was for 11 days solid, just sort of focusing down on this very small area. And it's called the ultra-deep field. And what Hubble came up with was that. Now that is an area of the sky in which, as far as we knew, nothing whatsoever existed. Every single one of these is a galaxy. That's a face-on one, you've seen. That's one that's onto the side, like the Sombrero galaxy. These are galaxies. That's a galaxy. These are all galaxies. And this is an area of the sky where nothing was happening. So what's going on in areas of the sky where there is something happening? So it really is absolutely astonishing. This is the moon, and this is the deep field here. This is the area of the sky to scale that Hubble was looking at. Tiny, tiny little proportion. And again, you sort of look at there was nothing there, except of course that there was. And if you blow it up even more, this is the photograph we saw 2 ago. Galaxies, 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 galaxies. Wherever you look, there's galaxies. These will be an awful long way apart, of course. You know, they're not next door neighbours or anything. But certainly, you've got an awful lot going on here. Right, by no means least, this is a thing called the day the Earth smiled. And this is from the Cassini mission again. And this is a photograph which was taken by Cassini. And it's on July the 19th, 2013. And what you've got here basically is an eclipse. The sun here is behind, this is Saturn. The sun is behind it. So Saturn's sort of eclipsing the sun, and Cassini is back here, and you're getting that. Now, the thing to do, you want to squint really hard here. Is look at this sort of area through here, that area. And if you do squint really hard, what you'll see is that is the Earth. And NASA knew, of course, that this was going to happen, so they publicized it. And on July the 19th, 2013, they said to everybody, you're going to get your photograph taken, so everybody wave when you go. So, of course, we all did, and that's fine. You can actually go in a little bit more. That's the Earth. That's the Moon. Yeah. Absolutely amazing. And I say any science which can manage to do that can't be all bad. Thank you. Yeah, yeah.
Would anyone like to ask a question?
Can I just congratulate Chris on the quality of the slides? Yeah, they've been absolutely outstanding, and it's helped so much to appreciate what's going on up there, Chris. I've seen many slides, many presentations, but this was superb. Thank you very much.
Thank you. Thank you. Well, thank you very much. I mean, I take no credit for this, really. I mean, this is the Hubble Space Telescope is doing all this work. But if you go on the NASA website, it's amazing what you can find on there. Really is. But yes, I mean, you can't go wrong, can you, with some of it? I mean, it's absolutely jaw-dropping, some of the stuff. I mean, it's one of the things, I mean, I still get it now. I've been doing astronomy now for a number of years. And I still get it. I look up in the sky and I'll find something I haven't seen before, and you get what I call the wow factor. You sort of look at it and go, wow, you know, and it's you know, the sheer joy and wonder of what's up there is just it's mind blowing.
Well, Hubble transformed everything, didn't it?
Yeah.
I mean, I've got a 4-inch reflector, which was great, you know. But once Hubble came on the scene, I mean, everything changed. I felt amazing.
Yeah.
To me, it's absolutely fantastic that all that is up there somewhere.
Well, it's all there. I haven't made any of this up.
And how on earth did you manage to find all this out, Chris?
It's known, Dorothy.
It's known, well, none of it was known to me, I assure you.
John.
Chris, just to have a feel once again for size, because it's so dramatic, and in our science group, I still haven't recovered from this observation that there are more stars in the sky, or even more galaxies than there are grains of sand in our universe. I mean, that is what I cannot grasp when you think of the size of all that is around us. Can you just substantiate, Chris, that this is really true?
That's true. That there are more galaxies in the universe than there are grains of sand on Earth. And that's one of those facts you've got to sort of go into a cave and sort of think about it for a year. You know, it's one that you don't immediately grasp it.
How on earth did they find that out?
Well, you count them, basically. You get an area of the sky, how many galaxies are in there, what's the area of the sky, multiply it by the whole of the sky, and you come up with a very large number.
Well, absolutely.
Chris, could I come on to that wow factor when you showed those readings?
So people can hear that.
And you showed those readings.
Yep.
And it was stated that the the hydrogen molecule conformed to that. Surely that's a coincidence. Unless it happened again and again, you could say you could provide that information almost anywhere.
Yeah, the wow signal has become known. I think these days we've almost got to look upon it as an anomaly, I think. You're quite right. in science, you've got to be looking for repetition. You've got to see things occurring as a pattern. And the wow signal appeared once and once only. And it is slap bang on right as a hydrogen atom. For this to happen by chance is incredibly slight. So it probably is a candidate for communication with another species. But you're quite right, it's never been replicated, it's never appeared again. And SETI, really, the people who have sort of been involved with it are really quite disappointed because we have had this thing called the Great Silence. We've been looking now a century, probably. And that's the one thing we've ever found is that, and it's spot on. You know, it really is spot on. But we've never seen it again. So, you know, what was it? Don't know is the answer. Is it proof of another civilization? Probably not. No. It's one of those things you've just got to sort of leave in the back of your mind. And if, say, tomorrow, there's another one come through, you sort of think, hang on, maybe there's something to this. But as it is at the moment, I think you've just got to treat it as an anomaly. And unfortunately.
What's happening with the successor to Hubble?
It's going to be launched in 2 years. I mean, Hubble has lasted longer. A lot of these things do. I mean, the Cassini mission to Saturn was designed to last for 2 years. It actually lasted 14. You know, the Mars rovers, which you've got up there, there's one which was put up there 20 years ago, I think, and it's still going strong now. So, I mean, once you do get these, I mean, it is actually very difficult to land rovers on Mars, and the majority of the ones which they put up have actually crashed. You know, there's only a few of them are actually functioning, which is a bit worrying if you want to put men on Mars, because it does appear to be very difficult to land safely on there. But yeah, I mean, when these things succeed, they succeed brilliantly. Jeff. So. Oh, yeah.
Can you hear me? Yeah. You mentioned that we're coming to the minima of the sunspot cycle. This is cycle number 24. And it's been the lowest sunspot cycle since 1878 to 1890. And then we had some of the coldest winters on record. Now, I know we're going to get climate change and everything's warming up. But I'm going to say in the next 5 or 6 winters, they're going to be colder than normal if the sunspot cycle is true to form. Because you always get cold winters at the minimum of a sunspot cycle.
We did the astronomy group in the summer. We actually went over to Rugby Club one afternoon and actually set some telescopes up to have a look at the sun, do some solar observing, and we managed to see the sun fine. But boy, was it boring! There was nothing there. It was just there wasn't a sunspot to be seen. You know, it was. I mean, it's interesting to see the sun, but there wasn't really very much going on there. So again, leave that for a couple of years again, and we'll probably do it again, and perhaps we'll have some more interesting things to see. But yes, you're right. Yes, we're really at a minimum at the moment. Yeah.
I thought that was absolutely fascinating. Oh gosh.
Any more questions?
Stunned.
Very interesting subject. Switched off. It's a very interesting subject. It's not switched off. Well, I didn't know anything about all these stars. I hadn't any idea that there were so many of the stars, and supposedly there'll be more and more.
Yeah, we're not even scratching the surface. I say, if dark material, the theory of dark material is right, we know a little bit about 5% of the universe. 95% of the universe, we haven't got a clue. I mean, that is, talk about the grains of sand business. I mean, that 3,000 years or what have you, we've been doing science, and we've managed to sort of discover a little bit, about 5%. 95%, we haven't got a clue. That's a bit depressing, isn't it, really? I mean, but anyway, that's where we are.
Well, how on earth did they come? How did the earth become the earth and the sun become the sun?
Let's do the easy questions first. It all comes back from the Big Bang, Dorothy, really. The universe started 13.7 billion years ago and just went sort of zoomp like that.
Well, how do they know that?
If you look in the night sky, all the galaxies which you see, this is just from observation, all the galaxies which you see are moving away from us. And the further away they are, the faster they're moving. Now, if you mentally, say, rerun the video, at the moment the galaxies are all doing that. So stop, let's rewind. So they're all coming back together again. And in the end, they all come back together into a point. And this is where the Big Bang came from. So it just comes from observation, really. There are other elements of it. Again, I won't get into this, but there's a thing called cosmic background radiation. And if the Big Bang is true, then you would see certain sort of patterns in the sky. And that you actually find. It is there, and you can actually see that. So again, it's evidence that the Big Bang took place. In the old days, you'll recall this, in the old days of analog televisions, if your signal went off, you had black and white dots coming down the screen. That's the cosmic microwave background radiation. Your television, the old analog television, can actually pick it up. And it was actually shown in your front room. That's it. The science is a bit complicated, but you can actually prove that the Big Bang did happen.
Better than some of the programs.
Yeah, indeed.
Well, that was absolutely amazing.
If the galaxies are moving away faster and faster, you mentioned that the Andromeda galaxy would be crashing into our galaxy. Would you expect that to happen when something was expanding? I would have thought that would not happen.
Yeah, that's it's an anomaly, really. In generality, all the galaxies are moving away one from another. If you happen to get one galaxy which is, for whatever reason, formed very close to another, then the force of gravity will overreact that. And what you do is get the galaxy. There are examples, I haven't shown any slides here, but there are examples of galaxies colliding up there. So it's not just Andromeda and the Milky Way, it's just Andromeda is our next door neighbor. And you say the photograph I showed, if you could actually see Andromeda up in the sky, it is huge. It dwarfs a full moon. It's massive. It's one of these things, if you sort of look through a pair of binoculars and expect to see the Andromeda galaxy, you won't, because it's too big. What you want is something which is really very, very, funnily enough, very low magnification to sort of see it properly. Almost every single galaxy in the universe is what's called red-shifted, which means it's moving away from us. Andromeda is what's called blue-shifted, and it's coming towards us. And it will, in a few billion years' time, you've got time for a cup of tea. It's not going to happen tomorrow. But it will, Andromeda and the Milky Way will collide. And actually, it probably won't, I was saying about bangs and crashes, it probably won't really make an awful lot of difference, because galaxies basically are 99% empty space. So even if they do collide, the fact of something sort of hitting our sun or something is probably very small, actually. We're not going to be around by then, because the sun would have swallowed the Earth, so we won't be around to see it. It will happen.
The sun will swallow the Earth.
Yeah. I shouldn't have gone there. Sorry.
Are there any more questions? No. And then I would like to thank Chris very much for giving us enlightening us, giving us such a great talk about things I didn't know about the galaxy, about the other life in the solar system. Please help me thank Chris.